circles and parabolas.
Okay. You have
Yeah.
problems you can verbalize, and we can work them. That's
Yep.
the best way, really, to explain all of them is to do the problems they give you.
Yeah. So the first one is 5x squared minus 4y squared minus 40x.
I didn't hear the rest of it.
Oh, sorry. Minus 40x.
Minus 40x?
Yeah.
Let me close my door. Hold on. All right. Sorry about that.
No worries. Minus 40x minus 16y.
Okay.
Minus 36, and it wants us to put this into the correct form, the equation,
Okay.
and then it wants the center, the asymptotes, and the foci.
Okay. This is the standard format for a polynomial.
Okay.
In other words, you don't always get it in the format of the particular conic section that you're dealing with. So the very first thing we have to answer is, what kind of conic section is this? Is it horizontal or vertical?
It would be vertical.
Well, first of all, what is it?
It's going to be a hyperbola.
Correct, because the x squared has a different sign in front of it than the y squared.
Mm-hmm.
And it's important. In other words, if you'd have given me this, that's actually an ellipse.
Okay.
Okay, so just because there's a negative sign doesn't necessarily mean it's a hyperbola, because the first thing I'm going to do here is divide both terms by -1, and then I'm going to have x squared plus 3y squared, and that's ellipses. So,
okay,
just as a word of warning, in case you ever run into that, those would be on the tricky side. So it's definitely a hyperbola, and is it horizontal or vertical?
Vertical.
Actually, it's horizontal if the negative sign is in front of the y squared.
Okay.
Okay, in other words, let's write the general formula over here. So x, in other words, whenever you have this, regardless of whether the A is under the Y or the B is under the Y, so if the negative sign is in front of the Y, then it's horizontal. If it were vertical, it would need to be y squared minus x squared. That would be vertical. In other words, horizontal or vertical is not determined by the A and the B, but where the negative sign is.
Okay.
Okay. So, and this all has to be equal to 1. So we can see, what are we going to do to put this into this format?
We're going to have to complete the square.
Yeah, that's the strategy we're going to use. First step, let's put the 36 on the other side, and let's group the x terms and group the y terms. So I got 5x squared minus 40x, put parentheses around those, and then we have, and this is not trivial either, what do we have here?
We have, if you take out the 5?
What I'm doing is grouping the x terms and I'm grouping the y terms.
Yeah.
And I'm going to put parentheses around them. And the key is to not change it from the original expression. So what goes in the parentheses over there? I know I'm going to move the 36 to the other side, but what goes in these parentheses? Because this is where everybody makes their mistake, is right here.
It would be plus 16y, right?
There you go. It's 4y squared plus 16y. In other words, everybody wants to make that negative, but if I were to make it negative, then it actually changes the expression because this negative sign has to be applied to both terms.
Okay.
Okay, so whenever this is minus, and it always is with hyperbolas, in other words, every hyperbola you're looking at, that's going to be a negative sign.
Okay.
Make sure you get the sign of this term right here, the 16y. Make sure you get the sign of that right.
Okay.
I'm not kidding when I say 90% of students will get it opposite.
Okay.
Now, before we can complete the square, what do we have to do?
Factor out a number.
Factor out the coefficient of the squared term.
Yeah.
Okay, so on the left, what is it?
It would be 5, and it would become x squared minus 8x.
And I'll leave room to complete the square. And then over here, what are we going to factor?
It would be a 4, and it would leave y squared plus 4y.
Okay. Now complete the square and compensate on the other side.
So the first one would be plus 16, so 16 times 5. It would be plus 80 on the other side.
And the y term.
It would be minus 16 on the other side. It would be a 4 in the parentheses and minus 16 on the other side.
All right, good. And now, what do we have? What's our next line? In other words, we're gradually progressing towards this format. That's what we're doing.
Okay. So the next term would be 5x minus 4 squared minus 4y plus 2 squared equals 100.
Okay, next step.
Divide by 100.
Okay, so what's the next line?
Divide by 100. It would be x minus 4 squared over 20 and minus y plus 2 squared over 25 equals 1.
And now we're there, really. That's the general format. So tell me what... Now remember that A always goes with the transverse axis. Okay?
Yeah.
So if we have figured out that this is horizontal, based on the fact that the negative sign's in front of the y, that means the major transverse axis is that one, and that distance is A, and that means A is the value under the x variable.
Okay.
So A is the square root of 20, which is 2 root 5.
Okay. And B is the square root of 25, which is 5.
And C is what?
It would be, it's A squared plus B squared, right?
Yes.
It would be 45 and
Square root of 45.
Square root of 45, sorry. And you could...
Remember, whenever you're solving for C, your answer always begins square root up.
And you could pull out
whether
9 root...
ellipse or hyperbola.
Okay. And I was practicing in class today that the thing where you pull out the perfect root, you know?
So what is
So you could pull out a 9 and a 5.
Okay.
And that would give you 3 root 5.
And notice something about this, and that is C is always bigger than A or B.
Okay, yeah.
Okay? And that's because C is inside the hyperbolas, like that, and C is the distance from the center to the foci, and since A is the distance from the center to the vertex, C is always bigger than A, but it's also always bigger than 5 since it's equal to the square root of A squared plus B squared. C is always going to be the biggest number there. All right. So what did they ask specifically for?
The centered...
Yeah, let's list everything we know, which is the center, the foci, and the vertices.
Yeah.
Where's the center?
The center is at 4, negative 2.
And the foci
is at the foci, and
instead of labeling
this is a
graph, I'll just let you do it algebraically.
Sorry, I'm just kind of like the foci.
Take the x-coordinate of the center.
Do we take the x-coordinate or we take the y-coordinate?
Take the x. In other words, the C is the distance from there to there. That distance.
Okay, so would the foci be...
What's changing is the x-coordinate. The y-coordinate is going to stay the same. But the x-coordinate.
Okay.
So you take the center and add
3 root 5.
Yeah, so the foci is going to be 4 plus 3 root 5.
Comma, negative 2.
And 4 minus 3 root 5, comma, negative 2. And let's see, the vertices.
It doesn't ask for the vertices, it asks for the asymptotes.
Okay, that's harder. That's good. I was going to say, if they didn't ask for the asymptotes, let's figure out what they are. You understand the asymptotes are, here, let me just draw this box real quick. The asymptotes are the diagonals to that box.
Yeah.
The slope on that diagonal. Distance is B, and the other distance is A. Slope is rise over run, so the asymptote's slope is what?
The asymptote's slope would be...
Yeah, you get the slope of the asymptotes from the rise.
B over A.
You got it. It's B. A, that's the slope of the positive one, and the negative slope is negative B over A.
Negative B over A. Okay.
So if they want the equation of the asymptotes, this one gives you what? Y equals...
Y equals...
the equation of that dotted line.
5 over...
Hold on a minute. I need to get my book on this. I've got it open to the right. I had it open to the right page.
Well, actually, I'm just sending you right now. I forgot to send it before the tutoring session, but those sheets that I was mentioning...
okay. Yeah, no, that's good. Although I think I want to look in my book anyway.
Oh yeah, yeah.
Just because I'm so familiar, I'm going to make sure I've got the right.
Uh-huh.
Um, this
So
one's
I just
a little
sent you,
complicated.
yeah, just sent you the sheets that we're going to be allowed to have on the test.
Okay. Yeah, here's what the equation. If the center is at the origin, then there's no y-intercept, so the equation of the asymptote is going to be b over a times x. In other words, just it's y equal mx plus b, but b is 0.
Okay.
B being the y-intercept, not this b.
Yeah.
If the center is not the origin, and you're dealing with a horizontal, like we are, then the equation is y equal plus or minus b over a times x minus h plus k. I mean, that shouldn't be that hard to remember. That's like vertex format, almost.
Yeah, we have that. Yeah, we have that one on our sheet too.
Yeah, and if it happens to be a vertical hyperbola, then the asymptote is plus or minus a over b times x minus h plus k.
Okay.
So they're very similar. The only difference is it's b over a instead of a over b.
Okay.
Okay, so this one's definitely b over a. So now, to get that equation, let's plug in everything we know, and what's our equation going to be?
K.
I like the fact that it's plus or minus.
Yeah. So b over a would be 5 over 2 root 5, but you can't have a
Well,
root 5.
yeah, let's worry about that when we're done.
Okay.
We'll
2
that
root,
irrational number.
2 root 5 x plus 4.
Here's the equation right here.
Yeah.
So what's h?
H would be, it's minus 4,
Plus
but would it be?
Plus 4, you're right. But it comes out minus 4
Okay.
because the equation is x minus h. You're correct that h is 4, a plus 4.
Okay.
I thought you were saying x plus 4, and that wouldn't be correct. But what's k and what's k?
K equals, would it be plus 2?
Negative 2.
Negative 2.
Negative 2. Here's our center right there. And our center is h and k.
Oh, okay.
So you could read it right from the center, or you could pull it from the equation. But it's a negative 2.
Okay.
Okay? And then now, I don't like rationalizing numbers in the middle of a problem. I prefer waiting till the end. Because sometimes, particularly with trig, you will find that if you rationalize early and then you're looking for the reciprocal, you need to rationalize again, so it makes more sense to not rationalize early. So if we do rationalize that, what does it become?
You divide everything by the 2 root 5. Correct.
Well, the only thing we really need to worry about rationalizing is the root 5. So what we're going to do is we're going to multiply top and bottom by square root of 5.
Root 5.
Which is the number 1. In other words, you're always allowed to multiply any fraction by the number 1.
Okay.
When we do that, we get 5 root 5 in the top.
And 2 on the bottom?
10. Well, we got the root 5 times root 5, which is 5. And then 5 times 2 is 10.
Okay.
Now I can simplify it. And instead of 5/10, I'm going to make that 1/2. So that's what it actually rationalizes to. And then everything else is still the same. So
Okay.
That is the equation of the asymptotes.
Mm,
And the only thing we didn't specify was the vertices, but that's what is this vertice over here on the right going to be?
the
They're going to give you a variety of problems, and they're all going to require you to know how to get every single one of these things.
okay.
Now, what's
So
the
it'd be
vertice on
the
the right?
it's the distance from the center to A, or it's distance from of A.
Yes. Yes.
Yeah.
The distance from the center to the major vertice is A.
So you would add in minus A to the X term, so that'd be 9.
4. The center is 4. Start with the center.
Okay, wait. Wouldn't you add it to the
X coordinate of the center.
the X coordinate?
Uh-huh.
Wouldn't it be 4 plus 5?
We're going horizontally.
Yeah.
For this vertice right here, the y coordinate is going to be the same as the center.
Yeah.
But the x coordinate is going to be the center plus a.
Yeah, so if the center is at -2 or 4 comma -2, wouldn't the vertices be at 9 comma -2, -1 comma -2?
Well, I'm going to take the x coordinate of the center, which is 4, and I'm going to add a to it. That's
okay.
And then,
I was
the
confusing.
y coordinate doesn't change. The y coordinate was -2.
Oh,
So
okay.
that's the vertice on the right. Vertice on the left is 4 minus 2 root 5, that distance a, and the y coordinate does not change on those vertices. So that's everything there is to know about that hyperbola, starting with the original polynomial. And if you can do that with any polynomial, regardless of what the conic shape is, you're going to be in good shape.
Okay.
Okay? So that's the name of the game, really, is to be able to figure all points of all 4 conic sections.
Okay.
All right, what else? What other?
One of similar nature.
Okay.
So it's 25x squared minus 4y squared plus 100x plus 24y minus 36 equals 0.
All right, this time I want you to tell me the next line, what I should write.
Your next line would be 25x squared plus 100x minus 4y squared plus 24y equals 36.
Okay. Now what do we need to do as a step here?
Factor out the...
Put parentheses. I need to put parentheses.
Oh, geez.
And that's tricky. Because the moment I put parentheses around the y term, I got to be careful I get the sign right on the y coefficient.
Yeah.
Okay? I can't really talk about factoring stuff out and completing the square until I do this.
Okay.
And it's so important because it's different. What do I got to do to that 24y the moment I put parentheses around there?
Flip the sign.
So it becomes minus 24y. And then just as a double check, make sure that we haven't changed anything. Everything's exactly the way it was, because if I then remove these parentheses, I got minus 4y squared plus 24y.
Yeah.
Okay? All right, next line.
You would factor out the leading coefficient of the squared term.
Okay.
So For the x, it would be 25, 4. Okay, so it'd be 25 parentheses x squared plus 4x, and then leaving space for like the...
Okay. I prefer to do it one step at a time rather than trying to do multiple things at once.
Well, yeah.
Factoring out that coefficient, let's only do that in this step.
Uh-huh. And then you'd factor out again, and it would be 4 parentheses y squared minus 6y equals 36.
Okay. Now what?
So now we complete the square.
Okay.
And you would half the middle coefficient and then square it. So that would be 4 times 25. So then you'd add 100 to the other side.
Okay.
And 3 squared equals, so you'd plus 9. And that would be negative 9 times negative 4. And that equals minus 36 on the other side.
Okay.
Oh, so that comes out to 100. Okay, so now your next line would be 25 x squared plus, or whoops, not x squared. X plus 2 squared minus 4 minus 3 squared equals 100.
Okay.
Yeah.
Next line.
Now you divide everything by 100.
Okay.
Yeah. 100. So that gives you...
Excuse me.
X.
1 second.
Oh, no.
Working through that. My dog just refuses to shut up. Hi, what are you barking? Hi? Come here. Come on. Come on. Come on in. Yeah. I didn't say on my chair, but that's okay. All right. So what's the next line?
It would be x plus 2 squared over 4. And y minus 3 squared over 25 equals 1. Is that correct? I think that's correct. Yeah.
Yep. So now we need, let's just list the stuff. We need the center, we need A, we need B, we need C, and we need the vertex and the foci.
And the asymptote.
Coordinates and the equation of the asymptotes, yeah. Okay? Yeah. Start with the center.
Well, that's just negative 2 comma 3.
A.
I have a question. So why is A always under the x term in hyperbola?
It is. Both of these were horizontal hyperbolas.
Okay.
Because the negative sign, it was x minus y and not y minus x. If it's y minus x, then the A is going to be under the y term.
Okay.
Remember, A is the measurement always along the major transverse axis. And when I say a horizontal hyperbola, the major transverse axis is horizontal.
Okay.
That's why A is under the x. If I'm talking a vertical hyperbola, the major transverse axis is vertical, so then the A has to be under the y.
Yeah. So why is it in ellipses the A is just always the bigger term? Doesn't matter whatever it's under.
Don't know. Don't know the answer to that. It probably has a lot to do with the definition of ellipses and hyperbolas. In other words, there is a strict mathematical definition of an ellipse. and it's the sum of the distance between the foci and the ellipse itself. The sum is always the same no matter what point you choose. As long as you draw a straight line from one foci to the edge of the ellipse and to the other foci, that distance is the same. And that's how ellipses are defined, and hyperbolas have a similar definition, but hyperbolas, it's always the same difference, not the same sum.
Okay.
So that definition is what creates different formulas for C, for one thing. In other words, the formula for C in an ellipse is not the same as it is for a hyperbola.
Okay.
So I can't really answer your question, and I don't know that you need to have it answered.
Yeah.
All you need to know is which one the A is under.
I was just wondering about that. Just popped in my head. So the A is 2.
Okay, B is
5.
C is
the square root of 29.
And C is actually plus or minus the square root of 29.
Oh, okay.
Because C is going to go in both directions. One will be plus, the other will be minus.
Okay.
Okay. So list the two foci.
It would be
Without me drawing, I'm not going to draw it this time because you can really get all of these from the numbers.
Yeah. So, it would, is it plus A? No, that's the vertices. Okay.
Well, first of all, A and C are both going to be measured on the X coordinate. They're going to be measured on the same axis as the major transverse axis. So
okay.
To figure out which to add C to, it's the X coordinate of the center.
Okay.
Okay. So where's the foci?
It would be at, so that's -2. -2 plus square root of 29,
comma
3.
Okay. And the other one?
Oh, whoops. And then another one would be -2 minus the square root of 29, comma 3.
There you go. And finally, let's see if I can remember. You remember what it is? It's plus or minus.
Plus or minus.
Without looking on your sheet.
Yeah, without looking at my sheet. It would be plus or minus A over B.
It's B over A when it's a horizontal. Because remember,
B over A
is going to be along the x-axis, which is the run.
And B is the rise.
B is a vertical measurement, so it's the rise. So it's got to be B over A whenever we're dealing with these kind. And then
okay, so X minus H.
Okay, which means
plus K.
So give me the numbers.
Oh man. Okay. X minus H would be, if H is -2, so would it be +2?
In other words, yeah, you don't want to. It's fine to write the general, but they're going to ask, and you got to do the specific. And I'm sorry, I should have put the B over A. I don't know why I left it in the general. Here, what is B over A?
5 over 2.
And then plus K, so what is it?
The +3.
And that's the answer you would want to get. In other words, that, and it is a straight line. Those are straight lines, so I need a Y over there also. I can't just say asymptotes equals that. The asymptotes are straight lines, and this is the equation of both of those straight lines.
Oh, okay.
Okay. Do they ask you to graph it also?
Not on that one. There's a couple problems earlier that they asked to graph if you want to try one of those.
Well, we can, but this was rather interesting for me. I would say I always get this after graphing it. And it's just almost like today that I realize you really don't have to graph it. If you recognize that it's horizontal, then you can get every single, the only thing we didn't do is the vertex. Did they ask for the vertex?
No, they don't. But the vertex is h plus a, right?
Uh-huh.
So it would be -2 plus, okay, so that would be 0, comma 3.
What's the other one?
And -4, comma 3.
Yeah, there. And again, I don't think there's anything else to get from that hyperbola that we didn't get without drawing it. So you know how to draw it though, right?
Yeah, yeah. Mm-hmm.
All right. Doesn't really do much good for me to draw it. This is the one time where I really wish you had a drawing tablet, and I can make you the presenter, incidentally, with GoToMeeting. It's easy to make your screen the one we're both looking at. And if you had a drawing tablet hooked up, I'd be tempted to say, turn it on your screen and graph this thing.
Huh. Yeah.
But
sorry, I don't have.
No, that's okay. No need to apologize. I think you get it. I think you could graph it from all of these numbers that we're looking at here.
Yeah.
All right.
No.
What else?
Okay. So this next one's it's off the review now.
Okay.
Let's
hope it's something that's different than a horizontal hyperbola.
Yeah, this one is.
Okay.
So this one says solve the systems algebraically and then graphically.
Okay.
And so the first system is y squared equals 13 minus x squared.
Okay.
And then the second one is x squared plus 4y equals 25. And then they want us to solve it algebraically and graphically.
Okay. I'm thinking that the easiest way, what's the easiest way? We got two ways to solve it algebraically. We can use elimination or we can use substitution.
I think substitution might be easier.
Okay. So tell me what to do.
So if we took the x squared plus the 4y and move the 4y over to the 25,
Good.
you could get x squared equals 25 minus 4y.
Okay.
And then we could substitute that in for the top one.
Yeah, and that solves one of the problems. If we were to solve for y squared, in other words, if we were to solve for y, rather, we'd have a plus or minus answer. And then we'd have to deal with that plus or minus answer when we substitute it. So there's a lot of logic in substituting x squared first. And that gives us y squared equals 13 minus, parentheses again, make sure
25.
Make sure you use the parentheses because when I remove them, it's going to change the sign on that.
So it would be y squared equals 13
minus 24. Go ahead and simplify the whole line.
13 minus 25 plus 4y?
Well, what's 13 minus 25?
Oh, 12. Or negative 12.
So it's negative 12 plus 4y, correct?
Yeah, negative 12 plus 4y.
Okay.
So
now our goal is to solve for x and y. So we have to solve for y. How do we solve that for y?
we move all the y, the we put them all on one side and have a 0 on the other. I don't really know how to say
Okay.
that.
So I got y squared minus 4y plus 12. You're kidding, really?
Yeah, plus.
Again, they give us one that I can't factor.
Is that not factor? Oh, no.
No, it's not factorable. It would be if it was a minus 12, which leads me to believe that we make a mistake. No, I don't see it. You definitely have to take 13 minus the quantity x squared. And the
Well, I wonder if it's, if you move the x squared over to the 25 side and move the 25 over, you'd have negative 25 plus 4y equals negative x squared, and that's the top term, and then you could just substitute that in. Or would that work? Does that make sense?
Well, there's only one right answer, regardless of how you get there. I didn't quite follow how you were getting there. Tell me again what you came up with.
So if you took the x squared from the x squared plus 4y equals 25 equation,
Okay.
and you moved it over to the right side, so you subtracted x squared from both sides, and then you move the 25 over to the left side, and you subtract 25 from both sides, you have negative
That can't change the algebra. There's no way that gives you a different quadratic. In other words, there's no way that two different methods that are both correct can come up with two different quadratics.
Yeah.
You know what I'm saying?
Yeah.
I'd be happy to do that, but I'm going to come up with the same quadratic.
Yeah.
And I'm trying to see if I made a mistake here. If I remove the parentheses, I got 13 minus 25 plus 4y, which is minus 12 plus 4y, which when you move everything over to the y squared, you end up with this. And not only is that not factorable, but if we examine the discriminant, it's 16 minus 4 AC, that's going to be a negative number. We don't even have real solutions.
So, do you think this one could be no solution?
No, it's a quadratic. In other words, it just doesn't cross the x-axis. In other words, it's a quadratic that maybe looks like this.
Huh.
It does not, if you have a parabola that does not cross the x-axis, then it does not have any real zeros. And no, it's got two zeros, what are called zeros, but it has two solutions, but they're both imaginary. And the only reason I know that is because I just checked the discriminant. And that's why the discriminant is an important is because you can immediately tell, even if you can't factor something, you can immediately tell whether or not it's got real solutions or fake ones. Well, just because it doesn't cross the x-axis doesn't mean it doesn't cross this other thing. The other thing being, well, hold on, let me think about this for a second. This is a circle. First equation. Okay, excuse me, let me back up a second. They told you to solve it algebraically and then solve it graphically, right?
Yes.
All right. So the algebraic solution, let me take that off there for a moment. The algebraic solution involves us using the quadratic formula to come up with y.
Okay.
And then based on that y, we can solve for x, right? Even if it's imaginary. And it will be.
Okay.
But even if it's imaginary, I think we can still solve for x. We're going to have x squared equals complex number, so we're going to have to take the square root of imaginary numbers. Wow. this problem would be so much easier if that were factorable.
Well, I looked it over. She didn't she didn't say she had a mistake or anything.
No, I don't think there's a mistake. Let's examine solving it graphically. In other words, algebraically, the only thing I know to do now is to apply the quadratic formula for this. That solves for y, gives you two imaginary solutions, and then you can substitute those in for this and solve for x.
Yeah.
Okay? That's an awful lot of arithmetic. Let's avoid that and go immediately to the graphical solution. Well,
Okay.
the graphical solution involves graphing that equation and that equation, not this one up here. This is a parabola, but that's not what we want to graph. We want to graph the two functions and see where they intersect.
Oh, I think I'm starting to catch on.
Number one is a circle at the center with a radius of root 13.
So that would be in between 3 and 4.
Yeah, let's just call it root 13. Right there is the coordinate of that circle for that point right there, root 13 comma 0. And now the second is what kind of a conic section?
The second is oh, wait a second.
It's got an x squared and a y in it. What does that make it?
I think I might have messed up on reading one of the problems off.
Okay.
Looking at it.
Doesn't, just before we leave this, hopefully that's true,
Okay.
and it'll turn this plus 12 into a minus 12.
But I think it's going to change the whole thing. Yeah.
Well, that's okay. Let's finish this since we got so far on this. What kind of a shape is that? Because they're giving it to you in a polynomial. You need
that would be a parabola.
a parabola, horizontal or vertical?
A horizontal.
No. What's the parabola
No, vertical.
you've worked with your whole life? Y equal x squared.
Yeah.
Well, that's what we're looking at. Y equal negative x squared.
Okay.
Not only is it vertical, but we know it opens down. Because by the time I put this x squared on the other side, I'm going to have y equal negative x squared plus stuff. Okay?
Okay.
So without us doing the math, just because we can get more done if we don't do the math, let's assume we're looking at a parabola that does something like this.
Mm-hmm.
We have 4 points of intersection, and those are 4 solutions to this problem.
Okay.
Okay? And you could find those on your graphing calculator.
Yeah.
You can also find them by solving this.
Okay.
But the parabola may not go up that far. The parabola may only go up that far, in which case there would only be 2 solutions.
Okay.
And in fact, what if the parabola went like this? There'd still be 2 solutions. The only time there's only going to be 1 solution is if that parabola is tangent to the circle and does something like that.
Okay.
You only have 1 solution. So,
and there's never a time it can be 3 solutions, right? Unless like one of the lines is tangent and one of them intersects.
Yeah. In other words, if you had, I hate this program. If you forget you're on erase and you touch the screen, it erases everything you're looking at.
Oh, that's kind of hard.
Yeah. So let's see. If I had a parabola that was tangent there, went up, came down there, I suppose I could have 3 intersection points.
Oh, okay.
Not positive, but it seems like that should be doable. Question is, can that parabola be tangent to the circle? In calculus, you learn all about tangents to curves, but the tangent is always a straight line. I'm not sure I've ever dealt with math where you have a curved line that is tangent to another curved line. Certainly, I guess it's possible because you can certainly have two circles that touch at only one point. So you can definitely have curved lines that are tangents, but I'm not sure about the math on those at all.
Yeah.
So where did you, what?
The 4y was actually a 4y squared.
That
Yeah.
does make things considerably different.
Yeah, because that changes the problem to a ellipse now, correct?
Well, that's an ellipse and that's a circle. So now, graphically, we're going to have the circle there, and maybe the ellipse would be like that. So we still could have 4 points of intersection, or 1 or 2, depending on if I move that ellipse left or right, I'm only going to have 2 points of intersection. Okay? So graphically, it's going to be whatever it is, and the way you do it, obviously, is put that in as one function, put that in as another function, look at it, and find the points of intersection. So graphically is definitely a much easier way to solve it than algebraically, but it does change everything here, doesn't it? Let's see what our algebraic produces now. What's the next step?
The next step would be to divide everything by 25.
No, we're trying to solve this system of equations. We're not trying.
Oh.
We're not trying to graph it or put it into standard format.
Okay.
Let me make another suggestion that if I write equation 1 this way, I can actually solve everything a little faster by elimination rather than substitution.
By elimination?
Yeah, hold on. I meant to write that.
Oh, I see how.
Yeah, we're going to subtract the two equations.
Yeah.
That's going to be x squared plus y squared equals 13. This is going to be x squared plus 4y squared equals 25. Subtract.
And if you subtract them,
get minus 3y squared equals 12.
Divide by 3. Y squared equals negative 4. And y equals 2.
Y squared equals 4.
Oh, y squared equals 4, sorry.
So y equals what?
2.
Plus or minus.
Plus or minus 2.
Okay. That plus or minus is going to be key because when we use the plus 2, it's going to produce a certain x. And when we use the minus 2, I believe it'll produce a different x. And so we'll have pairs of solutions.
Oh, okay.
Okay. So let's see if we can solve for x. Yeah, let's use equation 2. No, let's use equation 1. It's the simpler one. So substitute the first y in. What do you get? You get x squared plus 4 equals 13. So you get x squared equals 9. You get x equals plus or minus 3. And when I substitute the negative 2 in, I get the same thing. So we've got solutions that look like this. Y equals plus 2, x equals plus or minus 3, y equals minus 2, x equals plus or minus 3. Because when I substitute the minus 2, the algebra is exactly the same over here.
Uh-huh.
So what does that mean? If I were to try to graph that, my intersection points come at y equal 2 and x equal plus 3 and minus 3. So that's one. These two are intersection points. And the other intersection points are down here.
Yeah, below. It would be -2, -3, and 2 comma negative 3.
So let's see. If I draw that, I got intersection points there, 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 and there.
And then a circle.
Let's see. If I try to draw, oh, I got 2 circles, don't I?
Do you?
Yeah, I think we, oh, no. We have a circle and an ellipse.
Yeah.
Circle and an ellipse. So how could that work? I think we drew one.
I think the ellipse is horizontal.
Yeah, okay. Here, this will work. There's the circle.
Yeah.
There's the ellipse.
Yeah.
And there's the 4 intersection points.
Mm-hmm.
That's a little tricky whenever you're solving for 4 intersection points like that. It gets tricky in the fact that you have to put your solutions. In other words, the solutions are not y equal plus or minus 2, x equal plus or minus 3. You can't list those like that. You have to list them in pairs. In other words,
Okay.
this tells you that's one solution. When y is 2, x is plus or minus 3. So here's my actual solutions. If I want to list all the intersection points, I got 2,
comma 3.
I got
2 and negative 3.
3. I got
negative 2 comma 3 and negative 2 comma negative 3.
Yeah. So there's the 4 points of intersection. And that's really the way you would want to present your answer rather than this way. This way is a little confusing.
Okay. Huh. Okay. Cool. Well, thank you.
Yeah, you're welcome.
Did you get a chance to look at that sheet real quick? I emailed it to you.
Let me open up my email here. I didn't get it. You send it today?
Yeah. Huh.
Send it
That's
to
odd.
David Cowan 1949 at Gmail, or send it to my digital math tutor address.
I think it was Gmail. I'm just checking real quick.
That's the one I give to everybody, is the Gmail one, because that gets to me the quickest. But I didn't get it. You do need the 1949 after my name. Some people.
Oh, huh. Maybe it didn't send. Maybe it's in the drafts.
But
in a draft, it didn't send fully.
Oh, okay.
That.
Yeah, you can send it to me whenever, and I'll take a look at it when I get a chance.
Yep, it is on its way.
All right.
No worries.
Nick, I will talk to you next time.
Talk to you next time. Thank you.
Okay.
Oh.
I got it.
Okay.
All right. Bye-bye.
Bye-bye.